So that I would like to move to our panelists. And so I would like each of you to introduce yourself, provide kind of an introduction of your company and what you're doing with digital twins. So.
So good afternoon, everyone. My name is Faramarz Maghsoodlou. I'm the digital lead for energy industries. That's oil, gas, chemicals, power generation, and water for ABB in the Americas. For a lot of us who have been in the industry for as long as I have been, 35 years or so, some things keep coming back with a new name. I don't want to say digital twin is an old concept, but I remember back in the 90s, I was personally involved in building a high-fidelity power system simulator for grid transmission control centers, and we used it for operator training, system simulation. Of course, digital modeling and simulation, they have come a long, long way since then, but the concept has been there. So ABB is a 130-year technology company. We provide innovative technologies to digital industries. So our definition of digital twin, we view it as a digital representation of an object. The object could be a product, a process, or a system. Thank you. And this digital representation is animated by either real-time data or simulated data with the necessary fidelity to represent the performance and behavior of the object that's being modeled. The important thing, this is done in a certain context. So the context, the way we view it is, and by the way, we have, for this discussion, I'm looking at it from the point of view of process industries. So the context could be planning, could be design, engineering, construction, implementation, commissioning, operation, and maintenance. So the challenge with the digital twin, now let's actually start with the positive part of it. So digital twin, I think the reason it has become such a key word for us is it's kind of at the confluence of a lot of cool technologies. 3D scanning, industrial IoT, wireless, edge gateways and industrial edge boxes and applications, cloud, AI, machine learning, AR, VR, and so on. So we all see digital twin kind of bringing it all together. It's that one key that perhaps we all look at as finally unlocking this IT/OT dilemma that we have. So in that sense, it's new. It's definitely new, even though the concept has been there for a long time. Now, if you look at a digital twin, typically people think of it as kind of a visual representation, 3D visual representation of something, perhaps viewed through an AR lens or something. We consider it as very much context dependent. So the same object could have multiple digital twins. It depends on what you use it for. And the fidelity depends on that as well. So for planning, you may have one representation of the object. For operations, a different one. For maintenance, yet another one. So for a digital twin, I guess, implementation or initiative to be successful, you basically need three things. One is that you need an accurate representation, of course, of the object. The other one is you need an application that does the smart work of making use of that data, that model, and produces something useful. The third thing that we need is a platform that now lets you integrate the digital twin of an object with digital twins of other objects, so that you can, for example, go from a digital twin of a pump to one of perhaps a distillation column to that of a plant. So at ABB, we approach this basically in its full depth and breadth. It's all objects starting from individual equipment all the way to the whole plant, and it's across those contexts that I talked about. So from planning all the way to operation and maintenance and every step in between. So I would perhaps love at some point to talk about where we see this going, what are the challenges with implementation, and what's the future of digital twin. But perhaps we save that for later.
Sure. Thank you.
I'm Jaclyn Arnold. I'm with Hexagon PPM. I am looking after our asset owner solutions. Let me just poll the audience here a little bit because I get asked this question a lot. But who has heard of Hexagon before you came to this conference? Wow, I am so impressed. I'm just kidding. But normally people will say, well, who is Hexagon? And I'll explain our company, and then I'll say, have you ever heard of Intergraph? And they say yes. And if they say no, I say, what about SmartPlant? So they always know one of those. But we were acquired by the larger company of Hexagon about 5 years ago. Hexagon is a Swedish company. We've got about 20,000 employees or more. We do about 4 billion in euros sales. And we're in 60 different countries. PPM, which was the Intergraph company that was acquired by Hexagon, is one of the 8 divisions under Hexagon. So the way that we define digital twin, because I've learned that there's no shortage of definitions up here, but we define it generically across all of our divisions, and PPM has taken a lead on that. It's 3 things. I know you mentioned 3, but I've got 3 different ones. Connect, think, and do are kind of the categories of how we explain and distinguish our twins. So in the connect phase, this is the not fun phase. I mean, it's really about the digital depiction, but it's also the real-time and transactional, as Will had mentioned. But a few other aspects that we would like to add to that is that there are different levels. There could be the asset, it could be at a physical pump, and then it could be a asset within a plant, the whole plant, or enterprise type level. The other thing is it needs to be specific to someone's persona so that it relays information about what they need, when they need it, and what they need. And then it needs to be trusted. If it's not trusted, it won't be used and you won't get any value. So that's kind of how we sum up the connect. When you think about the do, part of it's fun, part of it's not fun. The digital twin has to coexist with what's physically there, and that's the not fun part. So our solutions aim at helping you connect it, but then also maintaining it. And then the fun part is applying the different advanced technologies. So once we do AI and machine learning, you can get those valuable insights about your assets, but also your people and your processes. And then the do is where all the value comes in. So these are the things that you're getting value from those insights of what the advanced technologies are telling you. We at Hexagon, we leverage the traditional Intergraph and our divisional technology to support that definition of digital twin and bring value. But we also use and look at all of the technology across Hexagon as one Hexagon. We have many different platforms. We have many different capabilities that's in our mining and our smart cities, that's in our government. And we take those and see how we can apply them to solve more solutions through digital twin to our asset operators. So we help you build it, whether it's a greenfield project being delivered as a digital project twin, or whether you're building it from a brownfield state of either doing some laser scanning, taking your P&IDs. But then as you start to adopt it and use it, we have software platforms that allow you to quickly after you've built it, we can show you the use cases of how operations and maintenance instantly get value from it, not just accessing it, but as they do their jobs day to day. And as you get ready to go up the maturity curve, we start bringing in situational awareness, which is more of the real-time information, geospatial type platform. And then, as I mentioned in one of the other panels we were on before, is that we partner with our clients on predictive and prescriptive using more of our AI and machine learning. So with that, I'll let you go.
Thank you very much, Jaclyn. My name is Tom Kurtz from a small German startup called SAP, for those folks that have had the pleasure. So I work within an organization called Digital Supply Chain. And I think for me, how that team or how that unit within SAP got its name feeds to this question, the somewhat elusive question is, what do we mean by digital supply chain? Or digital twin. So to start, I think I'll give the Tom Webster's definition. I think it's consistent with what I heard Will say, and to a certain perspective, what we've already heard is around a digital representation of a physical asset. I think that's what I would call the Webster's definition. However, what I like to then say is, okay, well, what does that mean to the average team, company, unit, organization who's looking at business processes within their organization, within their team? And so SAP does a lot with business process. So if I look at that pragmatically, well, what do we mean? That's where the digital supply chain name comes in. So the president, at the time we named our unit, the president at the time was spending time with one of our customers. And the customer was one of these half-day tours, and they spent a lot of time looking at the different machines and where the production plant was, and they were talking about the warehousing, and he was talking about how the engineering works and talking about the transportation and so forth. And by the end of this day, or this half a day, he turned to our president and said, I've now shown you my physical supply chain. I need you to enable my digital supply chain. And so that's what we call ourselves, because at that moment, she said, this is what we do. We help companies from design, the initial engineering process, all the way through to operations. And so when you think about that digital thread that goes throughout, there are implications of that concept. Again, going back to the Webster's definition, or the Tom Webster's, don't want to misrepresent here, of a digital representation of a physical object. That physical object is absolutely a physical object at the operations level, but it's a gleam in the engineer's eye at the engineering and design level. And there's many threads, many parts of that thread in between. And so a company like SAP works with many different companies in that process. We work with the original equipment manufacturers, we work with the operators. And so a lot of times, of course, and then an operator could be a manufacturer downstream as well to their operators. So that is the type of thing that we look at. And so maybe to close out then, to tie that into, okay, what does that mean in terms of how we have this conversation around that digital thread in the area I work in, specifically at the asset management world. So we talk about a portfolio intelligent asset management. And what do we mean by that? So historically, SAP has spent a lot of time with companies, again, with business process on the traditional EAM side, enterprise asset management. So the maintenance planning, the maintenance execution, work order management, and resource scheduling and so forth. So if that is the world of asset maintenance and operations, over recent years, we've had a lot of our customers who are already doing that coming to SAP saying, that's not good enough anymore. We don't want to just maintain our assets. We want to manage the entire life cycle of our assets. And so if you think of a circle, the way I like to draw it is a circle. The bottom half of the circle is that asset operations and maintenance. It's your scheduling, your work order management, and so forth. And then the top half of the circle, I divide into three categories. Companies want to be able to network and collaborate with their ecosystem. So the OEMs and the operators want to share that information. They want to be able to do risk criticality assessments on their assets. So things like RCM, reliability center maintenance, they want to be able to do risk-based inspections. They want to be smarter about how they plan their asset strategies. And they also, as we've talked a lot about, and I think this is where traditionally people always think about the digital twin side of it, is we want to be able to do more predictive simulation, or predictive monitoring, which could be condition monitoring, just taking that information, running alerts and thresholds against it. It could be more complex with machine learning. It could even be more sophisticated with physics-based simulation. And so, if that's the top three there, and then you have mobility around the whole thing. So to me, that's intelligent asset management. It's taking the asset operations and maintenance and then adding to it the APM, or the asset performance management, that you're hearing more about. So to me, the digital twin, again, you can think about it in terms of the digital representation of the physical asset, but how you instantiate that in your business process falls into all those categories in our experience. So with that, I'll hand it over to James.
Great. Thank you, Tom. I will do the same thing Jaclyn just did. So how many of you know PTC? I'm taking a picture here.
He's going to say that you asked the question, how good was James, right?
Yeah, thank you. Thank you very much. Again, my name is James Zhang. So I'm the VP of Strategy and Go-to-Market for our factory solution. For people you don't know PTC, PTC is a 35 years old software company. Our headquarters is in Boston. I would say this topic is maybe in the bottom of my heart. Here's why, because if even you look at PTC logo is really a P and a D, physical and digital. We believe that digital twin is really the convergence of physical and digital world. If you look at the past 35 years, we started business with computer-aided design and PRM. That one is more about build a digital model, the 3D model, the product context of the physical world. And then about 8 years ago, we start get into the IoT world because we believe IoT is bringing the data from the physical world to digital world, so you can make a digital twin is a dynamic digital twin. And then about 5 years ago, we made another big move is that make big investment into the augmented reality world because we believe another big dimension of digital twin is really how to translate the digital insight into actions and change the way of working in the factories, in the product world, in the service world. So this is really how we say digital twin. In summary, we say digital twin is really a digital model, can be a digital model of a physical product, physical object, can be a process. The process for the field, for the factories, can be something, a process of a single machine, or a whole product line, or even a whole factory network. And then third element of digital twin, we say, can be a person's task as well. If you look at how we converge this physical and digital world, it's really more about you have a digital model, and then you bring the data from the physical world to the real world, and use this digital insight, you can help the people to make better decisions to change the way of their working in the field. This really, you can drive a continuous improvement in your daily operations. So if you look at whole digital twin, we say the use case of digital twin are really across the whole value chain of industrial enterprise. The two biggest use case we say, one is about, we call it connected operations. This one is more about how to leverage digital twin to improve the field operations, to improve the factory operations, or people call it factory of the future. The second one, the second larger use case, we say we call smart connected product. This one is more about put the sensor onto the physical product and help customers to do remote service, to do the business model transformations. Like say, you can sell more service on top of your physical product. I mean, if you look at the market trends, we are the global leader of IoT, AR, CAD, and PLM. We say this is really a booming market, especially if you look at maybe 3-4 years ago, everyone say, what is this? What is that? These days, many times, more and more companies are getting over that pilot stage. They're more talking about how I get value at speed and at scale. We see this very great opportunities for everyone, and for sure, this is teamwork. This is why we have an alliance with Microsoft and Rockwell Automations as well. For sure, we are working with almost everyone here, and there's a lot of other companies. So we are very excited, and we have been seeing great value in the past 12 and 18 months. For example, from the smart connected product side, we see our customers report double-digit, more than 10% improvement on service efficiency. In the factory side, we see our customers say about 5 to 20% improvement on the machine throughput, and also about 5 to 12% reduction of cost of goods sold. So this is just exciting time. We are looking forward to working with everyone. Thank you.
Yes, my name is Steffen Wagner. I am the CTO from Process Automation within Siemens AG, located in Germany. And besides this, I have a role as a Digital Enterprise VP, driving the digital twin activities forwards in Process Automation. Starting with this, I mean, I don't want to repeat everything what's said before, but in a nutshell, our digital twin definition turns out into 3 major things. One is the product itself. It's the first part of our digital twin. The second part is the process or the production. And the third part is the improvement. Having said these 3, that goes along the whole value chain, starting from engineering and design at the beginning, through the operation of the plant up to the service. When we look through it, I mean, you can imagine, and what you see in the morning for the Audi case, when we talk about a product, we have on the discrete side, for instance, car manufacturers where we do the designs with our software together with these companies. So means there is a CAD program which builds the fundamental base at the beginning of the digital twin. Further on, over the life cycle, we increase value by having, for instance, simulation and tools which simulates the production or which simulates also the process for process industries. When we look through the process industries, for instance, we do have intelligence tools where we bring additional value by designing the process upfront and do the simulation over time and bring this then to life. When we go to the production sites and we deliver our software and our automation as well, the connectivity in the manufacturing sites, then the real capability turned out, and we're feeding back information from the real plant into our design phases, into our simulation phases, try to improve the designs which were made upfront, but also feeding this back into the earlier stages. And in the operation side and in the service side, when we would like to improve and the service capabilities, we heard one or two examples from the colleagues already. We are here to improve the assets as such by feeding this back by AI technology. Underlying of that, we do have our so-called MindSphere software, which is our connectivity, where we ping all things together. And it was said at the beginning, it's really crucial to understand the semantic of all the information we have. So the context of all information and to define this language, it's one point. And the second point is also the data federation or the data fabric, where to store this data and what bring additional value to them. And so this is kind of what we are doing right now to find this out together with our customers. We are running use cases dedicated in different industries and with different customers just to improve their actual manufacturing stage. So this is my short statement. Thank you.
Good afternoon. I'm Alan Kiraly. I'm a Senior Vice President at Bentley Systems. I run what we call our Asset and Network Performance Division, of which we have 4. Well, we're a private technology company, and we focus on infrastructure assets. So roads, bridges, tunnels, plants, but no widgets at all. And we've been involved in the whole life cycle for 30-some years, and we have everything that you need to design those, analyze those, and operate those. And if any of you have come to this conference over the last 10 years, you've seen a lot of our acquisitions have come out of this space over the last 10 years. Over the last 5 years, we've spent a lot of time by our founders, Keith and Barry Bentley, the 4 Bentley brothers are in the company, around technologies to go with and satisfy a need that we keep getting out of our user base. So when you're in civil construction and you're doing these big infrastructures, everything's federated, everything is EPCs and all over the place, and we continually are working on the aggregation of all this data coming from all of these sources. And so about 2 years ago, we announced our iModel.js open source technology, which is the basis of our aggregation of the 3. You know, you can put any data you want, but really its claim to fame is its 3D spatial capability to take models from all of these vendors we're talking about here, but also combine it with LiDAR endpoints and photographs and have a central place that's open and federated. So once you figure out what your digital twin is for you, you have a way of actually dealing with it because as these gentlemen and lady already said, you have to keep these things up to date. Once you figure out the work processes that are going to benefit from such a thing, and you figure out what data is, it has to be continuously updated, and that's not an easy task, and we think we've licked that, at least for the infrastructure space.
Awesome, thank you. So great introductions. Now I'd like to open for Q&A. If you have any questions, please raise your hand, and we'll get a mic to you.
Yeah, quick question. I heard several of you talk about the idea of creating twins and using it as a service model. But, you know, and I've heard that before, but question is, how come that's not accelerating more quickly than what we're seeing today? That set of service offerings, you know, across industry, across manufacturing.
So, yeah, you bring up a very good point. So one of the benefits of digital twin is that perhaps with the right kind of information model that is vendor agnostic and it's able to support the entire value chain, you could then get to a point where a product that's built by a manufacturer, installed by maybe an EPC, used by a customer, can be serviced by yet a third party, right? So I think at the evolution of the industry, the way we are right now, perhaps we are still within the vendor implementations of these things. And so the first step is to enable our own services folks to be using the digital twin to get the data, to update it, and then to provide feedback back to design and engineering and so on. The way I see digital twin is that ultimately I think we are going to get to a point where we go beyond just keep a digital model and keep it in sync. We're going to get to a point where we would have industry accepted information models whereby you as a customer can then rely on the digital twin to have enough of a representation so you can have products from different vendors and you accurately represent it. And then when we get to services, I think we will perhaps get to a point where we're going to train and certify service providers, where we can say, by the fact that you know the details of this model and you have demonstrated expertise, then we certify you to go and provide service on our equipment. So what we are doing at ABB is we fully realize that the entire board is not using ABB products. We are proud of what we have done, the systems that we have, but everything that we are building into our digital models, it's with the idea of having it be open to integration, because any facility you walk into, you're going to have, of course, different vendors' products on site. So I think it's going to take an industry-wide effort for us to go to a point where we have industry-accepted representations of these. So I see that ultimately where we can get to like autonomous operations, service provisioning would be remote and seamless and whatnot, but that's definitely a vision.
Maybe it's one topic. I mean, the question is to me, talking about the standardization of the information model, how far it is and how different it is in terms of the region in the world and who is doing what, if it's iModel or whatever. If you consider that the standard is evolving, the ecosystem will automatically grow because more and more companies will adopt to these standards. So what I see at the moment, the standards are not, so to speak, ready that everybody can jump on it. And maybe one or the other standardization body is willing to support this. This is my view on that.
Can I add something?
Yeah.
Yeah. So I think this question is more than technology for sure.
Yeah.
This is a business transformation. It's not technology transformations. So from our perspective, I can share with you some best practice we see from our own customers who are doing pretty good in the service transformations. The first one, I think this is really important that what is the routine you will take for this service optimization. Let's say you put the sensors on your product to try to make a service offer. You can start with your own service organization, just like Parman just said, or you can start with your distributor or ecosystem, or you can start with your end customer. This is really a strategic decision you have to make at the beginning of this transformation. And the second part is that I'll say the biggest challenge we see all these transformations in the industrial enterprise, no matter it's service, no matter it's factories, one of the biggest challenges we always say is change management. How to change the people's behavior, how to change the culture. I think on that part, really the best practice or success factors we say is that to have a centralized digital transformation office, very similar, just like Dow talked about this morning, put OT guys, technology guys, IT guys in the same organization, same office, use this team as a change agent to drive this transformation. This is, I would say, maybe the two things what I can think of. For sure, the third thing is really the technology foundation. I think speed really matters these days. I mean, it's not something like people say, hey, let's do some transformation, show me the result, show me the money in 2 years. That's not that case anymore. People want to see result as soon as possible. That's why you need strong foundation to do almost everything we are talking here, source the data, contextualize data, analyze data, and then orchestrate some process, engage people, change people's behavior. This is something critical part.
So Faramarz, you mentioned the phrase open to integration. So I'd like to extend kind of that to the rest of the panel and ask, what are your company's strategies around being open to the other technologies that are associated with digital twins?
I'll make a comment on that. So as part of our digital twin definition and some of the capabilities is being agnostic. We recognize that there's going to be multiple vendors in and things. So we are developing tools. Like one tool is that you could use our interop to bring in any type 3D model from any vendor. So we're not only investing in it from an R&D standpoint, but even our platforms that we're putting out can use some of the more cutting edge technology like edge computing and things to be able to connect in, but also still do traditional connectors like with SAP to do management of change.
Yep. Yeah, from an SAP perspective, I would concur with that answer. It's our experiences as well. I mentioned earlier in my opening, when you look at what SAP's history and really what we focus on is business process. And so we make software applications that help enable that. And so by definition, we're not trying to create every technology out there. We're trying to do the best thing for our customers to enable these processes. Now, we have a lot of software that can do that, but we recognize from the convergence of IT and OT, we've lived historically in the IT world. Some of the partners up here have spent time in the OT world, and by definition, when that converges, we have to all work together. My role prior to my current role, it was in our IoT technology group, and while that was very fun, exciting, futuristic in some ways, it was also very frustrating in others because it was almost the proverbial hammer looking for a nail. You know, we had these great technologies and we had an opportunity to go position it, but every conversation got into be the art of the possible. You know, you could do this with it, you could do this with it. But with the world of supply chain and manufacturing and operations, it's back to business process. So this is what we're trying to do. This is what we're trying to get better at. This is how we're trying to expand. Now we need technologies to do that. We have these different equipment manufacturers. That's not going to change. We're doing ERP with SAP, but when we're also doing this with other vendors, that's not going to change anytime soon. So if you're truly interested in making this the best solution for me, then we all have to work together. And that's the experiences that we've seen as well.
And our plan B is to acquire everybody.
Nice. Yes, just to add one or the other from Siemens' point of view, I mean, we know we need to expand our ecosystem. In the past, usually when I look through our DCS system, automation systems, we have a good footprint there. But nowadays, when we would like to increase to IT business, from OT to IT business, we definitely know that we need to open our ecosystems in this regard, which means from our cloud operating system, the Mindsphere product, we know that we have opened this, that application developers can easily access this. Even if there are third parties or others, everybody can access this from the top layer. From the connection side, from the edge connectivity, we are currently planning to introduce the industrial edge, which is also open ecosystem that everybody can join. We know at the moment, as you mentioned, speed is of matter, that we need to open this up. Having said this, on the other side, we are collaborating with guys like Bentley and others just to bring the whole portfolio together for our customers. And this is the third point, the ecosystem, not only driving on the technology side, but also bringing partners into play.
You can imagine when we talk about infrastructure, one of our divisions is digital cities, and when you're involved in a city, there's just no way you can't be open. So over the years, on the stuff on the big, large spatial stuff, we've been part of the OGC and the City GML standards. I'm on the board of Mimosa, which helps us with our EM integrations with the likes of Infor and SAP and whatnot. And like I said earlier, even we took the stand that you standards get frustrating when nobody's doing anything with them. And we did, like I said, with our my commercial with the iModel earlier. But to try to rationalize that with being open was the big decision, just to make it open source. And so you'll find that code in Team Center right now.
Right. Great. So this is for the whole panel. What have you seen as far as best practices when it comes to getting the quickest value from a digital twin initiative? Is it a pilot project where you get all the technology in one place and do kind of a small pilot, or is it a piecewise kind of, okay, let's get IoT in place, now let's get simulation in place? Can you maybe talk about that a little bit?
Okay. That's a good question, and depending on the customer, I mean, we figured out it's usually not one fit for all our customers. And what I see, and that's the reason why we have incorporated now a consulting team for that. Depending on the level of, I would say, digitalization in the company, there are various points where you can enter the process in building up a digital twin. No matter if it's in the design phase in the early stage, or you can jump in on every stage. I mean, as a result, the best is if you consider this in a greenfield plan, for sure, bringing everything from the beginning up. Then, if it's erected and then manufacturing is in production, but many brownfield installations are out there, which means to us, when a customer is approaching us, where to start, and then we're starting with a consulting project just to find the right spot where we dive into where's the greatest value to start with the digital twin.
I concur with that. I mean, I think it goes back to some of the business case 101, where it's where's the biggest need and where can you have the biggest bang. And a lot of times that's just finding a specific use case. It's we have this issue with this asset, or this asset's really expensive, or if it goes down, or there's a high severity. So most of the companies we talk to tend to have that initial piece that they want to look at. The other thing too, going back to my circle discussion earlier, sometimes it's where in the supply chain am I feeling the most pain. So there are some companies who they don't want to start right away. I mean, I know we traditionally digital twin is more about that physical asset and how do I get IoT data and so forth. But if we look a little upstream more and say, I want to be able to better segment my assets and change the strategy of how I set that up through things like RCM, I want to start there. And that's an easier place to start because my assets are defined in my maintenance systems, and it's not about figuring out the IoT technologies yet. It's figuring out my strategy, and then once I have that, I can apply that strategy to specific maintenance scenarios or asset scenarios. So I think it comes down generically to where is your biggest pain and where can you have the impact, and then that answer can be in different parts of your asset business.
I think, agreed, Tom. If you don't have a process to improve, you're going to be looking, when's your digital twin done? It feels like a warehouse kind of problem. But one pattern, though, that is very common now is just the democratization of data, if you will, that you can have on just these 3D representations. So you're in a plant, and everybody has their own system. And they could share data, but the only thing they really have in common between a reliability engineer and the design engineer and operations is they know what the plant looks like. And so just the simple thing of, you've got this SCADA data forever, and now you have IoT data, and some of that stuff is really valuable, and it's showing up on a reliability engineer's desktop, but then you want to design for reliability, but the engineering team doesn't really know how to get to that kind of data. And just to be able to synthesize that, summarize that, and just say, here it is, and do a contour, imagine like a contour map over your plant. This is where over the last 5 years we've had the most issues, or this is where this performance has been variable. It just quickly puts it in context, and it's not the end all. And It's just the beginning, but it gets people, to see where this can go. And it's not that expensive now to give that to that group. And so, so to prove that point, Siemens and Bentley have worked together on a product called PlantSight that was just for that, the application for everybody else to be able to see the data in the plant. So we believe in enough to invest in it.
So I can perhaps take this. So there are two examples that we can actually, we have demonstrated significant business impact for using digital twin. One, as I mentioned, is digital twin doesn't just apply to physical objects and products, but processes as well. So especially for greenfield projects, we have been able to run the entire plant, all of the processes, go through all the configurations, and look at the impact on cost, the infrastructure that needs to be built. And we have shown 20 to 25% savings in CapEx by being able to run all of these processes before even there is a single brick put on the ground. So that is significant. That is relying on the digital representation of the plant and the representation of the control system and the power system that are going to be serving it. That's one example, but I think the other example that is very topical, especially for process industries, is safety, unscheduled outages, and perhaps human error. So there are statistics that up to 5% production loss, up to $20 billion is what industries go through every year. 80% of these are preventable. 40% of those are due to human error. A lot of times human error is because the operator is overloaded with information, or perhaps they just, under pressure, they do the wrong thing. So digital twin is a powerful tool so that you can actually not only run through these training drills with them, but more importantly in a real context of actually operating something, doing a maintenance job on the plant. You can use a digital representation, overlay it, and I have seen demos, and I invite you to go to the ABB booth and take a look at what we have. So you can actually step by step take the operator through the steps of doing maintenance. However, this is also managed by a workflow so that you make sure that there are no mistakes. Every step is verified, and safety, human error prevention. Those are the top business impacts we have seen. We have actually demonstrated it. So,
Great.
In addition to that, what you are saying, more and more customers asking also for a so-called maturity level in terms of digital twin, saying where I am and what is the ultimate goal, distributed to several sites. And in addition to that, I mean, we need to bring all the data into the system over the time, and meaning bringing the dark data, which is not present or which is on paper, into the system. And having said this, it's from a lower maturity level to a higher maturity levels. I mean, maybe we see also in the future a more stable view in the world.
Yeah, so I just want to add something there because I almost agree everything we said here. So at PTC, I mean, we are lucky we have been working with maybe thousands of companies in the world, tens of thousands of factories in this factory transformations especially. What we say that our data show that so far maybe still 75% of companies, to be honest, still in that pilot purgatory these days. And if you look at this, the other 25% who are in this the journey of enterprise scale, we think there are really three things they are doing pretty well, or I call the best practice. The first one is these guys always start with this financial impact first approach. They get the executive alignment from the day one. They will say this double-digit impact in this area, there's a use case we are going to do. The second part they already do right is that they always focus on the most pricing problem. Can be a bottleneck in the factories or can be a machine issue in the factories. Because if this is bottleneck or most pricing problem, you can get value in very short time. Usually it's 3 to 6 months time. And then from there, the third thing they really do pretty well is that they have this foundation, not only platform, but also organization in place to help them to scale these capabilities from one factory, one site, to 20 factory, 20 site in only 2 to 3 years. This is really the critical path to get the success. I mean, just something add here. If anyone interested in this approach, feel free to reach out to me. We are having an article to be published this week in Manufacturing Leadership Journal about 4,000 words, talk about best practice of transformations in factories, about digital twin as well. Thank you.
Great. So James, you were talking about best practices. On the flip side, can you talk about maybe challenges and pitfalls that your customers have that you have to kind of guide them through, and then maybe extend that for the rest of the panel as well?
Sure. Yeah, I think the 3 challenges we say, number 1 is financial, really the financial, because now this is something get to enterprise scale, get to the table of CXOs, executives. These guys all about show me the money. So this is really a big challenge we say from our customers, because if you cannot show the money at the beginning, if you cannot get the executive on board at the beginning, you will always start in this pilot purgatory eventually. The second thing we say, a big challenge is really about lack of expertise, the change management part. You need someone who know almost everything. You know process, you know technologies, and also you know IT technology, OT technologies, you know operations. You have this domain knowledge. I think this is the second challenge we say many times. The third one, to be honest, is really the scalability, which is partially caused by the complexity of technologies. Just look at the people we are here. I'm sorry we are adding more complexity maybe to the customers. That's a fact. But I think this is really why, back to my point, you should start with financial impact. You should start with value, then get you into the technology decisions.
Just to add on to that, I think a lot of our clients have trouble getting started, not knowing where to get started or how to justify the value. So data is a big barrier. So once you get through and you're funded, because that was traditionally like a year or 2 years ago, we didn't have the funding, right? So we've gotten the funding, we've gotten the people, the C-suite support now, but we're running into like what James had said about not having the right skill set, but also not having the data that is trusted and cleaned and can be served up. And then you also have missing data. So you have all this data to figure out what to use, but then you have new data that you need to go out and get from sensors and things like that. So I think being overwhelmed and maybe making it bigger in your head than just taking some first tactical steps to attack a problem or process or people through technology, I think a lot of people get stuck in the pilot mode. That, and then I'll add one more thing. It's all the technology vendors that are coming at them, right? So all of us are talking about how we define digital twin, and it can just send you kind of in a whirlwind of not knowing, and you've got lots of startup companies coming and new hardwares and things like that. So it's just a lot to digest. I think at like what Dow has done by putting the operations center together, the digital operations center, helps navigate that faster and gets you out of those pilots and gets you the best thing to solve your problem that works for your company.
Yeah, I was just going to say pilots that are really science projects. I think if your pilots are real, you're using real data, you're really doing real value, and you've scaled it down to a real set of people, then that's an okay pilot. But just to do a proof of technology is just a waste of money. And if you can't find that and your organization's not ready to do it for real somewhere, you're just not ready, because you'll just have science projects after science projects, and you'll never end. So
Wait a minute, you charge for those?
Well, of course, we'll charge for whatever we can charge for. But yeah, we pretty much, to be honest, we would if we had the bandwidth. I mean, there are enough people out there today that really do have the wherewithal and have the real use cases to go after that. We'd rather spend time with them than people who are still just not ready to roll. I say another one is really, I think Tom would see it in his supply chain as well, is the commercials of the supply chain. Once you get serious, can get in the way too, because a lot of the data you want is owned by various owners across that supply chain, and they're not comfortable passing it up and down and being responsible for the integrity of it, and that's another big issue we see, especially on big mega projects.
From our standpoint, we said start small, scale fast, which means for us when we do our customer co-creation projects, we're running through the whole world. We identify the main purpose of digesting into digital twin activities. And when we start this and we run this in a so-called POC, where we place our product at one site, and afterwards we roll this out to several sites and just to bring this to a mature level. So this is our way forward in the consulting and in the approach of our customer.
So I actually don't have a comment on this, but if we're done with this, I had a question.
Go for it.
So yeah?
Yeah.
Okay, I'm going to switch it up a little bit here. So question for the audience. Show of hands. So as we've talked now for about an hour about digital twin and how we see it, based on what you're hearing, how many folks have already started a project that you would say is a digital twin related project? Show of hands. Yeah, okay. How many of you are thinking about doing something that you would classify as that? Okay, so we're relevant at least. I'm happy to hear that. Okay, that's what my question. I just wanted to make sure.
No, that's a good question. You'd think with as many people who are actively doing digital twins,
They're in the right room,
Yeah.
which is important. They're in the right city, but that's also helpful for us as we're having these conversations, and because I think that's about what I would expect, and there's probably a few variations, maybe a question 3 or very option C or D kind of thing, but I do think those are the people that are in rooms like this, the people that are in conferences like this, we're doing it, we're running into trouble, or we are thinking about doing it, but we're not sure exactly what that means yet. And so you've confirmed what I thought would be the case. So thank you.
We do have a question back here.
No, I was just going to, Tom, I was going to respond to what you're saying. And I'm with Dow and the DOC. I work closely with them. We do have digital twin pilots. I think the challenges that you all talked about and articulating why we want to do it and is there a value in doing it is certainly a challenge. But from a data perspective, we put a tremendous emphasis on getting the data from the real transactional system or the source system into a replicated system, and you'd appreciate this, Tom, because we use the HANA platform to do that, and that's really a big reason why we could do certain things that we would never been able to do before. Once you have the right data that's segregated and then you move it to the place where you can do something with it and then move it back into a target where you can actually demonstrate that you did what you were supposed to do. That is what's building confidence in the areas where we are able to demonstrate that. And I think we have to keep on doing that. Otherwise it becomes POCs or little experiments that that doesn't really drive the support that you need from the executives in the C-suite.
No, thank you for that. And you actually reminded me too, and this is consistent with something that Jaclyn was mentioning earlier. Data is a bit important part of these projects that we're seeing. In fact, one of the first what I would call predictive maintenance project that we had a few years ago was with a rail company, and that rail company came to it wasn't originally let's go do predictive maintenance. It was they were from a business perspective. They were trying to their maintenance. They're a pretty big company. Their maintenance line item started with the B. Right? They spend €1 billion a year just fixing broken stuff. And so 5%, 10%. I mean, that's a big. If we could save some money on that, that's a huge deal. So that was the original business case. But then it started out with, how do we manage this data? Because it wasn't just. I mean, it was all the systems. So you had a car. That car has doors. The doors break. They have brakes. The brakes go out. All the subcomponents that were part of this process. And so they had terabytes of data. So the good news is the manufacturers they were working with were at the point where they were embedded sensors. So they were getting this data, and they had no plan around it. So they knew they had the makings of an opportunity. They had a pain in terms of that big number. They had the technology in terms of the beginnings of the technology in terms of the raw data. They did not have a data strategy around it. So that's actually how it started, and then it kind of went from there. So thank you for pointing that out, because data management, and you heard some people say it in terms of some of the challenges, that's a huge part of the game.
It is. Great. We have a question up here.
I want to start with a statement, I guess. I'm a control engineer to start with, so you kind of get my frame of reference. I really want one digital twin that has the ability to look at a PNID that's synchronized with my 3D version of the plant, that's synchronized with my flow sheet simulator, that's synchronized with my dynamic training simulator, that lets me do control applications before I build the plant. Right? I want one digital twin to make that happen. Now, having been in a piece of every one of those, I know they don't play nice together. But what are we doing as the vendors to make that play nice together? I heard somebody mention something about doing some standard things. But how do we take that next step to make all that stuff go back to the beginning again when you make a change at the end?
So I'll take a shot at it real quick. One thing that Hexagon's doing is, we're seeking out partners, and we've been talking about everybody being ecosystem and everything, but we just recently, I think last June, announced our partnership with AspenTech, looking at how you take things back into the simulation and assess how you're running with your process information on top of your digital twin. So we definitely recognize, like Tom had said, we're not trying to recreate, reinvent everything that's already there, but we are being agnostic and pulling things together through partnerships in the ecosystem to make it easier on you.
And so I'll put my consulting hat on for a moment. With a question like that, I mean, the first thing, so it's a complex question. So, but as I would start to answer that, I mean, my first question back would be, do you feel like some root causes are understood there? Because my initial thought is, okay, what would have to change? So if you look at just the ecosystem you got up on this table, what would have to change from the product, the equipment itself? Is there information there that you would like to have, technologies embedded that you'd like to have that aren't there? From an IoT technology vendor perspective, is it about capabilities that need to be there that aren't there? And so you mentioned that some of these systems are known not to play nice. So then that becomes, I think about that from a business process standpoint. Is that about the technology, or is that about the governance models and so forth? So there's things, I mean, it would be a great discussion to have as a follow-up, but that would be I'm a root cause guy. So starting to understand why don't they play nicer together, and then of course figuring out where the low-hanging fruit is within such a complex problem. Okay.
Right. That's right.
Yes.
So being able to port all that data freely from the design,
Yeah.
your cost estimation, all that mess, your PNIDs, and then your 3D diagrams into the flow sheet simulator, and just have all that, the data's already there, because that's where we go look for it.
What I can tell you, we from Siemens, we work with two companies on that in Europe to find an answer in this. We are in the starting phase in this, and let's wait and see what we can show you during the year.
See, I believe the value case is there, because when we have done this manually, that whole process, right? You get to the end, and your operators have been trained on this high fidelity simulator, and you start up the plant, and everything just works better because they kind of know what to expect before they even have the plant finished.
Yeah, maybe we can follow up this a little bit.
Yes. So from ABB's perspective, as I said earlier, so we do have the capability to do the full simulation of the plant control system and all the processes. We are very open to partnerships, because if all of the equipment is not ours, of course, if it's ours, we have all the models. But if it's not, the way we have designed the platform that I mentioned initially in terms of integration of digital twins of different types. So in the context of, for example, control. So we are very much open to partnership, right? So we have a library of models, and we are open to, and in some cases, we work closely with the customer so that they facilitate that as well, so we can get a full representation of the entire plant. And we have done this, and this is the best way to do it, because before you build a plant is the time you have to run your simulations and see where you can cut costs so you don't overinvest in infrastructure. So for example, we did this for a very, very large plant, and the simulation that we did was for the control system, the process automation system, as well as for the power system that supports it. We showed 30% improvement, just for not having to build additional power infrastructure to support the plant, because it could be verified upfront. But back to your point, I think we need more collaboration, more partnerships, and we need to build those platforms in a way that new models can be plugged in rather seamlessly. So.
Let me add to especially the comments here as well. You asked how. And it's not easy, right? So the solution that Bentley and Siemens came to together was we had to co-invest in something else, because the problem is, as was just about the ROI, is everyone knows it. It's just the pain of getting there, right? And can we really ask each engineering department to fork over there and change their tool? Nobody wants to change, and so we stepped back and said, everyone's repository is their own repository. How can we, instead of being the single source of truth, be the single visualization of truth, right? And so we started with the PNID 3D problem. Yes, well, we had the 3D stuff. Siemens had the PNID stuff, but it's grown from there, and that's been launched, and we have early adopters of that going, and we would really, the process stuff's coming next, and it's going to be the current process vendors because. And solutions, because it's really the only practical way. And I think, as vendors, we want something that we can reproduce as a software vendor, not have to do a bespoke in each time, right? So anyway, it would be very good. We'd like to get your feedback of where's the MVP there? You mentioned that whole thing. Is just if it just had the is there a logical incremental start steps? We think so, but we need more validation that we're doing it kind of in the optimal order.
Yeah, I think maybe one more topic, maybe I add a little bit complexity on this conversation is digital thread. Because if you look at digital twin, it's really through the whole asset life cycle, from the design to construction to commission, operate, the whole life cycle. What we say from our experience these days is that I can give you an example. This is one of the largest independent unconventional oil producer in West Texas. We have been working with them for 2 years, and they see great values. They can produce more oil, all this stuff in their artificial lift system in 85 stations now. And then I met with the their chief data scientist about, I think 3 months ago. The conversation started with, hey, we want to get enterprise scale. We cannot build all the models by ourselves. How can we leverage the model from the OEM? This is something you say, the connections between the OEM and what operator needs. This may be back to your topic, right? You need really this digital thread in place to ensure this two worlds are talking with each other. I mean, for this OEM, this is really more about new business model, the service optimization. But for the owner and operators, this means lower the barrier much, much more. I mean, this is not something one company can do perfect answer or magic there. It's really ecosystem play. Everyone's part of it.
Great. So I have kind of a two-part question. So one is for the panel, and that's what are some misconceptions that your clients have when you start working on a digital twin initiative with them? And then on the other side of that coin, for the audience who is doing some sort of digital twin initiative, because we know you're out there now, Are there any instances where you're having trouble getting your suppliers to really understand your pain points, and how is that communication working?
I'll take a first stab. So misconceptions. I think this is less now, but to a certain extent, when you get with the IoT topic, there's a couple things there. I think I've worked with some groups that see it as too futuristic, especially with the work that we do. So we have work with a partner, ANSYS, who's in the room today, and they've lived for many years in the engineering simulation space. So on the engineering side, how do you accelerate your validation process? And so now as we move that into the operations world, a lot of their customers are saying, we want to do this, not just, we want to extend, basically. We want to create the digital twin. We want to extend these designs, and we want to be able to know how they're working in operations. We want to take that model and actually leverage it and merge it with IoT data. We're doing this today. We have products today that can do this, and we have customers that are doing this. But some customers will hear that and they'll be like, "That's Star Trek, right? That's science fiction. We can't do all that now." And so that's today. I think within the last couple of years, you're seeing it with maybe some of the IoT technologies, and so that was one misperception. I think that we're getting over that now because the technologies are more adopted now as a result. But I think that's something that we saw for a little while.
I'll comment. One thing they always think is it's too expensive. That's a misconception. But I mean, basically, the cost of getting into it detours some people, but the value that's there and not understanding what return they're going to get from it always helps aid that conversation a little bit more. The other thing is that I always hear, well, we don't have a 3D model, or we don't plan to maintain a 3D model. You don't have to have a 3D model. We have one of the largest chemical companies that's working off our situational awareness platform and has been for 15 years using just 2D drawings. It's the center of their plant. They have 200 different use cases that they use it for plant-wide, and it's off of their plot plans, and it's off their P&IDs and everything like that. They don't even have a model. So I think you can start with what you have, and your twin can be a digital thumbprint for what you do have, and it doesn't have to look like what everybody else may have.
So I take a quick comment on this. So one of the misconceptions is that, especially when it comes to digital twin, people often think of it as technology shopping. It is not. So that's the biggest mistake, I believe, because with digital twin, just like any other digital transformation project, it has to start with a business case. And it's not necessarily, well, I want AI, and I really like to have big data, and well, do you have 3D modeling, and can I use? It's not that, right? So you have to start with what's the business case, and what does it take to do it? It's not necessarily checkbox of all the technologies that says, I need all of these. And these are the type of things that happened 3-4 years ago. And I think the industry has already been through 1 or 2 cycles of this, and the vendors have become smarter with this. Nobody wants to buy technology for technology's sake. That's the biggest misconception I think that's out there. So for us, the conversation starts with people who run the business. And then we go to, well, what technologies that you might need here. So I think we shouldn't confuse digital twin with a shopping list of technologies. Yeah, that's the problem.
We have a question or comment in the back.
Yes. Will, you mentioned the ARC view of having a project's digital twin and an operations digital twin. And if there's a manual handover of information, which has been the traditional way in between those two things, it can really be a hindrance to the realization of the operations digital twin. So I'm just curious if any of the vendors are doing anything to ease the pain, frustration, and expense of that handover process.
I think we definitely do have some people that can speak on that.
Were you looking at me?
I'm looking at you. I'm looking at Bentley.
Absolutely. Handover. I was in Australia earlier in September, and I met with 8 or 9 different owners, and every one of them told me the same thing. They said, we will give you millions if you can help us figure out the handover problem, because they've already gotten into projects. They didn't define what was going to be in the contract, and they didn't know what they're going to get back from their EPC at the end of the project, and then they just keep hitting the repeat button. So Hexagon realizes that we're very involved with CFOS as it's evolving as the standard. And we've built our SDX platforms around, we have SDX projects, which allows the collaboration back and forth during the project phase. It allows you to get the deliverables in a smart manner. And then it allows you to go through your management of change process and bless that over into your operations as you start to commission and operate the plant, which is our SDX operations. It's no manual moving of anything. It's all the same platform. It's just about how you manage the change of going from a project into operations.
Yeah, same. If I understand it, the same kind of thought. Trying to do it though with us not providing the platform. So with like Mimosa objects, you need a schema, right? And you don't want to get into schema hell where we can't get started without a schema, but you need to have some common schema, right? So using, we say it's not about technology, but you got to have the technology doing the right things. So, using the things that have been learned in software, like the success if you're of GitHub with pull requests and that kind of thing, the optimistic and pessimistic stuff that GISs have always had, where you can take a piece of the thing and then put it back and merge it. Those things have been proven over the last 20 years, and you can be just re-implemented and reused for this use case. So trying to pull that together and get that as part of the process, because if you don't look at it holistically, the only way to solve it is to be in one big tarball, and you probably don't want that anymore.
Great, thank you. So we have 10 more minutes. I've run out of questions, but if you want to give any closing statements or ask any questions of the audience, go right ahead.
Who's more confused? Anybody? Hopefully not. We did good.
All right. Well, we do have a question. Great.
Thank you. I've been thinking about this for a little bit. One of the earlier panelists in another session mentioned they were telling the story of their digital transformation progress. And they said, first thing, we bit the bullet and put wireless throughout our plant. Is that a requirement for digital twin? And is that a big obstacle? You get in, your customer says, I want to do a digital twin, and you go in there and there's no network anywhere in their facility. Can you still do anything? Or do you tell them, go do your plant and then call us back?
We have a lot of users that aren't connected to the internet. So no, it's not an obstacle at all, right? I mean, there's still, it's going to be useful, but it's certainly not a prerequisite. I thought you were going to go the other way. They spent their entire budget going wireless, and now they can't do anything with it. So, I mean, horses for courses, but I mean, it's going to be helpful, but, none of these things are requisites, and I think that was well spoken. You can use what you got. And I think that's the important thing. If you know what business process you've got and you got an ROI, you can digital twin enough, right, to show progress and then make it better from there. I think any of those other types of obstacles that are like, I can't do it to this technology barrier or all my data is clean, then you're just making excuses, right?
Yeah, I would say it's hard to argue against having plant-wide wireless. And it's always a good thing. However, I agree with what was said. It's not necessary because, again, with digital twin, you're going to be focusing on a specific KPI. For example, there may be certain type of critical assets that have more than usual failure rates, or certain equipment is suspect, right? Or quality is deviating, and so on and so forth. So what we would recommend is that, in the old days, sensors and all the instruments came baked into the product, and you either had it or you had to live without it for 20 years. So now with this, non-intrusive sensors, you can actually buy wireless sensors, attach it to the side of the equipment, measure temperature, vibration, anything you want. And so you can be very focused in how you spend your money because you know what you're going to be discovering or what you're interested in. So while I would never advocate not having wireless in the plant, I would say it's absolutely not a necessity. You should focus on exactly what pays off. And that could just be targeted instrumentation of some critical assets.
So we never tell them to come back to us later. But we do, I mean, it changes the requirements, right? As long as you have the technology stack that can deal with the different requirements of whether they need to do some work packaging offline to where it caches what they need and stuff. And so as part of our connected worker and all of our point apps, we consider that as part of a requirement. Are we seeing, like we had a forum, I think last year in June, where this question was asked, and most of the owners in the room had started implementing some type of connectivity for their plant. So I guess I would like to turn that back around. Who in their plant today has no connectivity and no plans for setting up connectivity? No, nobody?
Some in the back.
Okay,
but-
so there's a couple. You have no plans to do it? Okay. It's not a ton, but if you have to look at the different markets too. So if we go into the mining, that's where they have all set up connectivity now, but naturally they didn't have anything to be able to connect to, but they broke through that. But so it just changes requirements.
So the thread I heard on this that I think is consistent with what you've heard today is the technology should not drive the process. So if what you have is what you have and what you need to do is what you need to do, you react to that. Now, as part of that plan, there's a technology investment work stream, if you will, or a component to that you're looking at. But if you start with the tech, and who knows the context of how that session was used previously today, but if you start with the technology, you're potentially doing it backwards because you're potentially gonna get into you're letting the cart lead the horse, so to speak. In my opinion, and it sounds like maybe in the opinions of some of the folks up here.
Yeah, I just want to echo that. I think this wireless connectivity is great to have, but not necessary to have. If you start with the financial impact first, start with value first, eventually you will say, what are the use cases of digital twin you will have? It's kind of digital twin of a machine there. Already there's wired connectivity there. Or it can be something like you use AR, like we call digital twin of people's task. In that case, maybe you will need a wireless network. This really has to be the second piece of conversations.
Okay. Any more questions? Any questions for the audience or last words?
So short break, and then we'll come back for the next 90 minutes?
Yeah, I think that's the plan. Okay, that concludes our digital twin session. Give it up.